What is turndown ratio? Turndown ratio is the ratio of maximum measurable value to minimum measurable value of an instrument while maintaining acceptable accuracy. Formula: turndown ratio is equal to maximum measurable value by minimum measurable value. Example: if a flow meter measures, minimum flow is equal to 10 cubic meters per hour. Maximum flow is equal to 100 cubic meters per hour. Turndown ratio is equal to 100 divided by 10 equals 10:1. Why is turndown ratio important in oil and gas plants? Because process flow rates change frequently due to startup, shutdown, low production, peak production. A high turndown instrument can measure both low and high flow accurately. Example: gas pipeline may operate between 20 million standard cubic feet per day to 200 million standard cubic feet per day. What is the difference between rangeability and turndown ratio? Turndown ratio, instrument measurement capability. Rangeability, control valve control capability. Example: flow meter turndown 10:1. Control valve rangeability 50:1. What is the typical turndown ratio of common flow meters? Flow meter turndown ratio: Orifice plate 3:1 to 4:1, Venturi 4:1, Vortex 10:1, magnetic flowmeter 20:1, Coriolis 100:1, Ultrasonic 50:1. Example: gas metering stations often use ultrasonic meters because of high turndown. Why does an orifice meter have a low turndown ratio? Because differential pressure depends on flow squared. When flow becomes very small, the differential pressure signal becomes too small to measure accurately. Why are Coriolis meters preferred for low flow applications? Because they have very high turndown ratio, up to 100:1. Example: chemical injection system. Flow range: 2 kg per hour to 200 per hour. Orifice cannot measure accurately. Coriolis can. What happens if flow goes below minimum turndown? Accuracy becomes very poor. Example: flow meter turndown is equal to 10:1. Range is equal to 100 meter cube per hour. Minimum measurable flow: 100 divided by 10 equals 10 meter cube per hour. If flow becomes 5 meter cube per hour, reading is unreliable. What is turndown ratio of a differential pressure transmitter? Typical DP transmitter turndown: 100:1. Example: DP transmitter range: 0 to 1000 mm of water column. It can be ranged down to 0 to 10 mm of water column. What is the practical turndown ratio used for orifice flow measurement? Though transmitter supports 100:1, orifice meter is limited to about 4:1 due to Reynolds number limits, TP measurement limitations, accuracy loss. What is the effect of turndown ratio in custody transfer measurement? Custody transfer requires high accuracy. If flow varies widely, multiple meters, parallel runs, are installed. Example: gas metering station, 3 ultrasonic meters, each operates within optimal turndown. What is turndown ratio of control valves? Control valve rangeability typically 30:1 to 50:1. Example: valve maximum flow is equal to 500 cubic meters per hour. Minimum controllable flow 500 by 50 is equal to 10 cubic meters per hour. What happens if a control valve operates below its rangeability? Problems: valve hunting, poor control, oscillations, seat damage. Example: valve designed for 100 to 500 cubic meters per hour. Actual operation 5 cubic meters per hour. Control becomes unstable. How does turndown ratio affect flow meter selection? Engineers check minimum flow, maximum flow, required accuracy. Example: flow range 10 cubic meters per hour, 200 cubic meters per hour. Turndown required 200 by 10 is equal to 20:1. Orifice cannot handle, choose Vortex or Ultrasonic. What is the turndown ratio of a Vortex flow meter? Typically 10:1 to 20:1. Example: steam flow 100 kg per hour to 1000 kg per hour. Vortex works well. Why is turndown ratio important in flare gas measurement? Flare systems have extremely variable flow. Example, normal operation, 5 meters per second gas velocity. Emergency flare, 60 meters per second. Range change is huge. So ultrasonic or thermal mass meters are used. How does Reynolds number affect turndown ratio? At low flow, Reynolds number decreases. If Reynolds number is too low, flow becomes laminar. TP equations become inaccurate. This limits turndown ratio. What is practical turndown ratio for ultrasonic gas flow meters? Typical 50:1. Example, gas pipeline, 10 million standard cubic feet per day, 500 million standard cubic feet per day. Ultrasonic meter works effectively. What happens if instrument turndown is smaller than process turndown? Measurement error increases. Example, process flow range, 5 to 200 kg per hour. Turndown needed, 40:1. Orifice meter, 4:1, unsuitable. How do engineers handle very large turndown requirements? Methods, multiple meters, dual range transmitters, different meter technologies, parallel control valves. Example, gas station, low flow meter plus high flow meter. How do you calculate required turndown ratio? Example, process flow, minimum is equal to 50 cubic meters per hour. Maximum is equal to 1000 cubic meters per hour. Required turndown. Turndown ratio is equal to 1000 by 50 is equal to 20:1. So instrument must support greater than or equal to 20:1 turndown. Thanks for watching. Please subscribe, like, share, comment. IIQA